So far when talking about atoms, there's been two ways that we've gone about describing them. The first way is what I'm going to call just a picture, all right, where we've just done a little drawing where we've drawn green circles, blue circles, and these little red circles to represent the protons, neutrons, and electrons. Another way that we could represent this exact atom right here would be like this, and I'm going to call this just a list of particles, where all we're doing is listing the particles and saying how much there are of each. Okay, there's 3 protons here, 1, 2, 3, 4 neutrons, and we've got 2 electrons here. But neither of these are the way that chemists usually go about describing what an atom is comprised of. The way that chemists typically describe an atom is through what you call an atom symbol or an element symbol. So here's what a typical atom symbol looks like. This symbol right here is going to be for this particular atom, and I'm going to go through what all these numbers mean. So let's go through how you go about drawing an atom symbol. So here's a generic representation of how you do an atom symbol. So first of all, you notice there's a big X here, all right? This could either be 1 letter or 2 letters, but it's going to correspond to the symbol for that element. So by now you should be familiar with the fact that the periodic table is filled with the elements and that each element has either a 1 or 2 letter symbol. Whatever the element is for that atom, that's what's going to go where this X is. So for every symbol, you'll notice there's 4 corners where you could put information. There's the lower left, upper right, and the lower right, all right? We're going to talk about 3 of those right now. There is going to be a use for what goes down here a little bit later. The number that's going to be represented in the lower left is going to be the atomic number. And remember that the atomic number is the number of protons in the atom. The number that's going to be in the upper left is going to be the mass number. And remember that what the mass number is the sum of the protons plus the neutrons. The upper right is going to be for the charge. And remember that charge has to do with the relative numbers of protons and electrons. So let's do this atom for example. We've got 1, 2, 3, 4 protons, 1, 2, 3, 4, 5 neutrons, and 1, 2 electrons. Okay, so the first thing that you're going to need to do is draw the symbol that corresponds to this element. So what tells you what element an atom is? It all has to do with the atomic number, which is the number of protons. So 1, 2, 3, 4 protons. Okay, that means for this guy, the atomic number is 4. You look at the periodic table, you find the element that has that as the atomic number, and we can see that that is beryllium. And the symbol for beryllium is capital B, lowercase e. So we said that the number that goes in the lower left corner is going to be the atomic number. So we can go ahead and just put a 4 there. The number that's going to go in the upper left-hand corner is going to be the mass number. The mass number is the total of protons plus neutrons. So 1, 2, 3, 4 plus 1, 2, 3, 4, 5. That makes a total of 9. So the last space is going to be the upper right, and that's the space that's reserved for the charge. Okay? So remember that the charge has to do with the relative number of protons and electrons. So the way that we can figure out the charge here is just by kind of canceling out the particles. This proton will cancel out with that electron. This proton will cancel out with that electron. We have 2 leftover protons. Each one of those has got a positive 1 charge. So this entire atom right here we know has a positive 2 charge. So what we're going to do is put a positive 2 up there. Okay? So this right here is the atom symbol that corresponds to this atom right here. This next one I'm going to do in a little bit of a different way, where instead of drawing a picture, I'm just going to give the list of the particles. But we should still be able to draw a symbol for this atom just based on this information. So first of all, what is the symbol that's going to go in the very middle of the representation? That's going to be determined by the atomic number, which is given by the number of protons. So the atomic number is 9. Periodic table says that that is fluorine. So you start off just by drawing a capital F. The lower left is the space reserved for the atomic number. That's a 9. The mass number is the total of protons and neutrons. So that's 9 plus 10. That's going to be 19. And the charge has to do with the relative number of electrons and protons. In this case, they're exactly equal, so there's going to be an overall neutral charge. There's just as much positive charge in the atom as there is negative charge. So the way you represent that is just by putting a 0 there. So I've chosen this particular atom right here to demonstrate something about drawing the atom symbols. First of all, what is the element going to be? The element is going to be sodium because there's 11 protons. And the symbol for sodium is capital N, lowercase a. The atomic number is 11. The mass number is going to be the sum of these two. That's 23. And what's the charge going to be? Okay, there's one more proton than there is electron. So what that means is that the charge is a positive 1 or plus 1. But there's something about when you draw an atom symbol when the charge is either positive 1 or negative 1, where you don't just put this number right here. The convention that chemists use is whenever the charge is positive 1, you just put a plus here. If it's a charge which is higher than that, plus 2, plus 3, you would write out plus 2 or plus 3 if you had that charge. But if the charge is only positive 1, you just put the plus, you don't put the number next to it. So if the charge is plus 1, you're just going to write a plus when you're putting the charge in the symbol. Keep in mind, if I were to show you this atom and say, what is the charge on this atom? You would have to say positive 1 or plus 1. All right? It's just that when you're drawing that charge in the symbol, you just put the plus. And so here's an example of an atom that's got a negative 1 charge. Okay? The element is going to be fluorine because there's 9 protons. That means there's a 9 right here. The mass number is going to be 9 plus 10. That's 19. And you've got one more electron, then you have protons, which means a negative 1 charge. Okay? But what we were saying is that when you have either a positive 1 or a negative 1 charge, you just put the sign. You don't put the number with it. So you would just put a negative sign right there. And when you read this, you look at that and you recognize that that means negative 1 charge. So keep in mind that you might have to go in the opposite direction. You might start with the atom symbol and have to figure out the number of protons, neutrons, and electrons from that information. Okay, so take a look at this atom symbol. First of all, how would we figure out the number of protons? There's actually 2 ways we could figure it out here, because the symbol right here essentially gives the same information as you would find in the lower left corner. Because the atomic number for chromium is always going to be 24. That means that there's 24 protons. So I've just gone ahead and drawn this generic atom symbol down here to help remind you of what all these numbers stand for. Okay? So the number down here corresponds to protons. Okay? The number up here corresponds to the sum of protons plus neutrons. So how do you figure out the neutrons? That's going to be the difference between these two here. So it's going to be 52 minus 24. And finally, how many electrons does it have? The way that you're going to figure out the number of electrons is through a combination of 2 bits of information. First, it's going to involve the number of protons, but it's also going to involve the charge. And the way I like to think about this is to think that this charge is telling you something, all right? And this is what he's saying. So essentially what this guy is saying is that I have 2 more protons than electrons, okay? How do we know that? The only way that he's got a positive 2 charge is because protons outnumber electrons. If you had exactly the same number of protons and electrons, the charge would be 0. If you had more electrons than protons, the charge would be negative. The only way that you have a positive 2 charge is for the protons to outnumber the electrons by 2. Okay, so here's the logic. If we know that we've got 24 protons and we've got 2 more protons than electrons, then what does the number of electrons have to be in order for that to be true? Okay, it's got to be 22, all right? 22 is the number of electrons so that he would have 2 more protons than electrons. So take a look at this atom symbol right here. The first thing that you'll probably notice is that it appears that there's some information that's missing from it, okay? I haven't put a number in the lower left corner here, all right? And I'm doing this to demonstrate a point about atom symbols. Generally, you put the atomic number at this position, but keep in mind, if you know what the element is, you automatically know what that number is, okay? We know that the element is nitrogen. What is the atomic number that corresponds to that? Okay? It would be 7. So we could draw in a 7 here, but it's not necessary because it's just giving you the same information that you already know based on what the element is. Okay? So I'm going to go ahead and put that number here just to make it a little bit easier to calculate these numbers. So, first of all, how many protons do we have? Looking at the generic atom symbol right here, the number in the lower left corresponds to the number of protons. We've got 7 protons. How many neutrons do we have? If this is the number of protons plus neutrons, and this is the number of protons all alone, then the number of neutrons is the difference between these. 14 minus 7 is 7. And electrons. What is this charge right here saying? That's saying that he has 3 more electrons than protons. That's the only way that he would have a -3 charge. Okay? So if he's got 3 more electrons than protons, and we know that he's got 7 protons, that means that the number of electrons he has got to be 10.